right, 74,193, okay? It's got a lot of pins on it, okay? But the two pins that I can always identify, 74,193, is the power and the ground. For most all TTL chips, the ground will be on the left side if you're looking at it with the little notch. By the way, some of them have a little circle here or here. But one way or another, that's the head of the chip. We count one and we go down and around the chip and back up, and this is the last pin. It might be 12, it might be 18, it might be any of those, okay? All right, 14, okay? So we start here, pin 1, and we go to, how many pins are on the 193? 16. So now I know that this is pin 8 here, and it's ground, okay? And the last pin, 16, let's see, let's put it on the inside here, is B plus. And when I say B plus, that stands for battery plus, and it's whatever voltage we're working at, which is 5 volts. Okay? All right, now, the main thing that we need is we need, well, we got power. We need to be able to output a 4-bit word. Okay? So we know right away that it's got to have 4 outputs on it somewhere. I believe they are Q0 through Q3. Is that not correct?
QA, QB, QC, QD.
Okay, that'll work too. So we'll put A, B, C, and D. All right? You may see them with number designations also. So, all right, so those are the outputs. Inside this chip, it has a little flip-flop again, by the way. And that flip-flop flip-flops over, and it causes a counting chip to, and it really turns out to be a whole bunch of flip-flops that does that. One flip-flops over, and then that triggers the next one, which triggers the next one, which triggers the next one, and so it counts, okay? But it's so put together so that when you put a pulse in, the flip-flops all flip-flop over, and they start counting 0, 0, 0, 0 is where we start, and when they're all flopped over from one pulse in, we end up with 0, 0, 0, 1, okay? And that will be on here. That'll be the 1. These will be all zeros. It will start with A, okay? And as I put pulses in the up count, because there is a down also, every time I put a pulse in, it counts one more binarily. So the next count will be 0, 0, 1, 0. Okay? This will be 0. This will be 1. This will be 2. And you know that because you know it's 2 to the 1, 2 to the 2, so on and so forth, right? And you add them all up. Remember that? Okay? So I just keep going. 3, 4, ... 9. And then after that, there's a bunch of weird squiggly stuff, and then it rolls over to 0 again, okay? This stuff we don't have to worry about. We just leave it alone. And we make sure we never count above 9. Where do we do that? Well, somewhere in here, we know how many we've counted up, so we just don't count past 9, okay? All right, now, it would be nice if I had some way to just go to 8 instead of counting all the way to 8. You know, I mean, your calculator, if it had to count all the segments to whatever number, it outputted, it'd take a long time for it to get it done, for one thing, and it looked kind of confusing. So all of them had to count, say, to 8, so they're all counting. And there was some old equipment that they had that used to do that, count through, but I won't go into that. It was pretty weird stuff. Some of the very first stuff was kind of weird. Anyway, okay, so I need a way to get to 8 right away. So what I do is I have inputs. What did they designate those as?
Data, AB,
Yep.
DD.
D1, DA, DB, DC, and DD. Okay? Now, I don't want those to be on all the time. They're inputs. I don't want them to be on all the time. I only want them to be on whenever I want them on. So what I do is I use a load. And you'll notice there is an L or a load in your data sheets. And that, when I bring, I think it's, is it high or low? So you got a little, has it got a line over it, or is it just open?
Just open.
Just open. That means to take it high. When I take it high, whatever these are connected to, that's what the word will be. Now, what did we connect them all to? Ground. But I could have connected, say, this one right here. I could have taken that one to high, 5 volts, and now I would have had a word 0010. And that would have been what number? 2. So when I do the load, I would expect to see on my display a 2. Okay, load 2. It also has a reset. When I do a reset, that will take it back to when you turn the power on. Okay? So if I do a reset, it'll go back to 0000 every time. Okay? If I do a load, it will load whatever I have on the inputs data, the data inputs. Okay? All right. Then there's the up, down. The up or the down just takes a pulse. That's all it takes. You have to decide which way you're going, up or down. Right? Are there any other connections that you're not sure about? I think there's a couple of connections for
Carry, borrow, and
carry. Okay, carry, borrow. Clear is like a reset. Okay, so it either says reset or clear. Either one of those work.
carry, borrow is to go over and use.
Carry and borrow. Yeah, if you got multiple counters, what happens is when you pass 9, then it will carry a bit to the next one, and you hook it to the up count or the down count, or to the carry borrow on that side. If you put it into the borrow or carry, then it will actually just keep track of it until it gets ready to use it. Okay, so depends on what it's loaded. Okay, so it can get really complex here, and I don't necessarily have to connect these right here to a power source. I could connect it to an Arduino, okay, over here, and then the Arduino could either load it with a 1 or a 0, so I could load in 4 bits of data from a programmable processor somewhere, and it could change it. And that's exactly what it does on a calculator. If it knows the number is 4863, it just loads them all and then displays them. Okay? It doesn't count all the way up to those. Okay? So that's how it gets the number in there immediately. Okay? All right, does it make sense? Okay. Where would you use the counter where you wouldn't load it? If you're doing a frequency counter, running a frequency counter, yeah, it counts up, then resets and counts up, and then resets because it's sampling and looking at the frequency. That's where it would just count up. Okay, it wouldn't load it. Now some of them do, but it wouldn't necessarily have to load it. The old ones all counted up that way. In fact, they didn't even use the displays. They used what was called a Nixie tube, which had a whole bunch of little things in there that lit up. It was pretty cool. Sometime if you ever get a chance, you can look at those. All right, so this is 74193. And that covers all of your connections. By the way, the outputs will drive 6 devices, just like all TTL stuff pretty much will drive 6 more devices, okay? If you have to drive more than that, you have to either put in a non-inverter, a buffer is what they call it. If you take the little dot off the front of the arrow on the 7404, you have a buffer. A buffer is a device that will drive devices ahead of it, okay? So if you have a problem and you need more devices to be driven, you just stuck a buffer on it and you got it. We good? Okay. So to look at what we did, we have our display. We have a 7448. That drives our display. We have a 74193. That just has an up and a down count. That's all we have to worry about once we get it all wired up correctly, right? The up or the down. And we have a 555, and it should be pulsing at some frequency that's slow enough so we can see it count. And we can attach that to the up or down. If we have a little pot on it, we can change the frequency a little bit, and it should count up. If I put it on the down, it should count down. Right. So that should be where you're at. If you're not, that's okay, because I know there were some issues and problems. Now, one more thing I want to talk about at this point in time. You need to start, and that goes for everybody, you need to start color coding your wiring. You need to start trying to make all the wiring for one particular thing a certain code and a certain length. So let's say the 4 bits that you're going to drive, let's say we make them all green. Okay? So we go, okay, the 4 bits between the 193 and the 7448, they're green. I can always identify them then. And if I make them the same length, I just over or pretty close, you know, I do the best I can, or at least group them together somehow. Okay, and I need to make them long enough so I can get the chips off the board and put another one on, because you're going to blow one up for sure.